Bismillah, alhamdulillah, salatu wassalamu ala rasulillah mabad. Welcome everybody to a short and brief tutorial about a program that I've just created in Python. So the program, first of all, this is Boumediene from Algeria. So let me talk to you about this program. So I've created a program. Let me first ls demo. ls demo. The program, its current name is demo.py. So let me vim it. So the program name is Whoisup2. I'm gonna call it Whoisup2 because I've already have or created a program called Whoisup, which is version 1, but this is Whoisup2. So I'm gonna share it with you. I'm gonna publish it in GitHub on GitHub, so you can go ahead and contribute to the file or do whatever you want. Okay. So the program or the purpose of this program is create a port scanner. It's like Nmap. I'm not comparing it with Nmap, but it's like Nmap. Okay, it includes the fin scan, the Christmas tree scan, the half open scan, and the null scan, and stuff like and other types of scans or other type of scans. So scanning techniques. So I'm importing here some important modules that we're gonna need to accomplish this program. So the threading, sockets, struct. Actually, I don't need the threading module, so I can get rid of it. For the time being, I haven't included multi-threading in this program, so I'm gonna perform it later on. So I've created a class here called injectMe, and I created a constructor. The constructor accepts some parameters like the source IP, des IP, source port, dport, and the protocol. So the reason why I didn't include all TCP and IP options here, because only these options must be changed during the execution of this program. For example, if you're gonna perform a scene scan, you have to of course we're gonna create the socket or the class instance and then call the object scene and set the value to 1. Okay, that's the reason why I've used only these options in the constructor. So if you're interested about how to create the IP header, I've just created a video, recorded a video about how to do a manual injection using raw sockets, and I've given an example how to generate an IP header as well as an ICMP header, which is an echo request, ICMP echo request, concatenate both headers and send it over the network and get a reply. Okay, so you can go ahead and check out my video about manual injection using raw sockets. The same thing applies to TCP. You can check out my videos, and simply put here, you're gonna understand this stuff in details. So I don't want to waste time in this video, so you can check out other videos. The same thing for receivers. You can check out other videos about raw sockets, how to create sniffers and injectors. So just check out my channels, and you're gonna find some useful tutorials for you. So these are the socket instances. Okay, so I created a socket to send to generate the packet, and I'm using the IP protocol here to enable the IP header include. So we're gonna include the IP header, and for more details you can check out the previous tutorial, manual injection using raw socket. I've explained this stuff from the manual page in details, okay, in more details. So these are the available options. For example, if you want to send any kind of flags, and for example if you want to perform a Christmas tree scan, actually you can go ahead and perform it and provide the xmask or the x parameter. So let me go ahead and do nmap -ss for scene scan, and let's perform the scanning against my router. And as you can see here, these are the available source. So let me Python demo and let me perform a scene scan, the same thing, and I am going to send it to my router on port 80. So as you can see here, the port is opened. Let me try 21, 22, 23, and 139 and 445. Excellent. So everything seems to be okay. So let me try with a different port, for example port that does not exist. As you can see here, the port is closed. So let me try it out with a Christmas tree scan. So the port is open, but what's the difference between a Christmas tree and scene scan? The Christmas tree scan, actually, let me do demo here, the pi. If we scroll down here, the Christmas tree scan actually would be set all these three flags to 1. These flags would be set to 1. The urgent, the push, the fan. According to TCP/RFC, the request for command file, if a packet that any packet that doesn't contain the reset, the SYN, and ACK flags, this is a useless packet and must be discarded. Okay, so for the purpose of this packet, our packet would be discarded. So what we're gonna do, we are going to generate a useless packet, send it to the service or to the system. If the service is available, our packet would be discarded. If not so, we're gonna receive a CNAC from or a packet with a reset ACK flags are generated by the TCP IP stack implemented in the kernel would be actually sent to us. So let me prove it. So if we're gonna send a packet here to port 445, and I'm running a Wireshark instance here, and let me do 445, and let me clear it and send a packet again. And as you can see here, we've sent a packet fin push urgent, but we haven't received anything. But if we're gonna clear it and set it to a different port, for example 666, and the port is closed, but if we filter it out here to 666 and 666, as you can see here, we've sent a fin push urgent, which is a useless packet, and we've received a reset ACK, a packet that has been generated by the TCP IP stack implemented in the kernel. That's the reason why I've used the timeout on the socket. If we scroll up here, that's the reason why I set the timeout. So if we're gonna try to receive the data, if any socket timeout happened or occurred, actually we are going to check out if it is a null scan or a Christmas tree scan. We're gonna print out the port has been opened. Else, if the okay, I've included the fin scan, so let's try it out. Let's try it out. I don't think it would work. Okay, it works. Let's try it with 445, and as you can see here, it works. And the same thing for actually for port 666, we have sent a fin scan, as you can see here, fin packet, and we've received a reset ACK, so which means that the port has been closed. So that's all for this video. You can actually go ahead and contribute to the file. I'm gonna publish it on GitHub, so let's move it demo to Whoisup2.py. So you can actually go ahead and contribute to the file, and if I'm gonna accept it, of course, if it's if you're gonna suggest nice or great ideas. Okay, so thank you for viewing this video. See you next time.